morning. My name is Andrej Abromic, and I work in the Eco-Aqua Institute at University Las Palmas de Gran Canaria. We are working mostly with the marine data, with the marine environment, and in this moment we have two projects on the marine spatial planning, which we have it. The first one is MARSP, with whom we are developing the data model for MSP, and the second one is project PLASMAR, which I mainly passed my time with this because I'm project coordinator and a technical developer as well. So we're not going to get in this project that much, but we are going to show how we actually apply INSPIRE principles within this project. So in 2015, we presented in the Lisbon the analysis where we actually studied how actually INSPIRE can support marine spatial planning. We analyzed the directives, we approached the geoportal to see the data availability within the marine basins in Europe. We also identify Plannend Land Use data model, and we see what is actually needed for adopted for the marine spatial planning. We also think that actually using this data model with INSPIRE services can be actually delivered e-reporting for the 2021, where it's actually scheduled within the Marine's MSP directive. And finally, we see within this analysis that using the INSPIRE services can increase the transparency of the MSP process. In 2016 in Barcelona, we showed how kind of results of the test, where we actually tried to see not what is the added value, how actually when we use INSPIRE as a tool, what is the technical needs and what can actually help us within the international project. So we updated one project, citizen science project within the INSPIRE, and we get some ideas what actually can be added value for the projects international. So the first thing, what we see there is a available number of open source tools. This is not a problem. We saw the data harmonization is quite useful, but can be hairy for the people who doesn't work with the data transformation. We applied one-off transformation architecture, but we had actually problem to share INSPIRE compliant file with download services. When we play in this model of INSPIRE compliant file, we actually can share the download services quite easily within flat model, but we also see the download services are quite useful for the frequently updated data. So all this knowledge, what we gather in this study and the knowledge what we get with the marine pilot, actually we included in the proposal, which project was accepted. In 2017, we started with the project PLASMAR, which on the Spanish, it's an acronym. In English, it's Setting the Basis for Sustainable Maritime Spatial Planning in Micronesia. It's a project that will last until end of 2019. It's a 1.5 million project. It's co-financed by the European Regional Development Fund within the Interreg framework. The main idea of the project is to define and propose the robust methodologies for the MSP and the blue growth development, but we actually are focusing on the biographic characteristic of Micronesian region, dealing with the balance between the blue growth and nature conservation. So we define this goal within the three, let's say, containers or the actions, and the first one, we want to develop the zoning method, new zoning method. And this is a kind of theoretical part where we identify what are the current uses in Micronesia. Within the current uses, we also identify the trends, and with this, we have a kind of projection for the next 5 years, and we know what are the actual sectors that we have to deal with it. We also analyze what is the state of play of implementation of Marine Strategy Framework Directive. We know that we can reuse lots of things, not just the data, but assessment, the program measures. So we analyze the first cycles, and we are now using it. And then we also map the environmental issues for the sectors that we identified. For all these sectors that we identified, environmental issues, we are also establishing monitoring program. We are developing the new methods, 6 new methods. But actually, the specific goal 2 is the one which we want to talk about. It's a development, it's a deal with the data collection and development marine data infrastructure. So it's nothing special there. We have catalogs, we are dealing with the metadata, harvesting metadata, data flows, and the data harmonization. But one thing what we identified very fast, that we have partners who already have a special data infrastructure, and we have partners who need a capacity building. So with the project that I mentioned on the beginning, MARSP, we make a collaboration within the capacity building, the workshops, and we we show the partners how to deal with the metadata, we show the partners how to deal with the download services, and what we actually make the hands-on, that actually they can try to share the data. And to do this exercise, we develop very simple data infrastructure. On the R server, we install a 3 Geo server, which actually the partners who doesn't have a special data infrastructure, they are using it within the data flow. So we are collecting data, and we have a kind of the framework because we want to have a structural collection of this data because we're doing it from the Canaries, for the Madeira, and for the Azores. So we have the first component is the data which are used for the Marine Strategy Framework Directive, also assessment. We need the data about the marine protected area, land use, the coastal land use, because we want to analyze the land-sea interaction. Oceanography, it's very important for us, like a temperature for the aquaculture and wind currents for the offshore, et cetera, et cetera. And finally, we have a maritime activities. For this data collection, we actually used a lot the European data initiatives like EMODNet and Copernicus, or the databases that are actually provided by European Environmental Agency about Natura 2000 and Water Information System. What is actually good within this, because they are providing the products. They are not actually detailed as the local data, but they are covering the whole Europe, or they are covering the Atlantic, or they are covering the Micronesia. Also, we are gathering data from the national or the regional sources, and we have partners who has already developed data infrastructure. And what I said before, 3 Geo servers that are actually using the partners who doesn't have developed data infrastructure. So we are actually collecting data to feed in the system, which we called INDIMAR. It's still in development. We want to, for all 60 parameters, find a relation for each of the maritime activity, and then actually get the maps where are the best places for the different maritime activities, where the environmental impact is minimized and where the environmental impact is higher or lower. But this is not something that I can talk about because this is another story. But I want to show you how actually we deal with the data. One of the first data set, and what is the use case, what we identified for the Canaries, it was coastal habitats maps. So this is quite interesting because we have 7 islands, and these 7 islands actually are, this survey is done with more than 8 companies. So each of the company did it on their way, and they provided different classifications. So we have 176 different classification and habitat. The Canaries, it's a quite high biodiversity place, but not that high. It's a semantic problem. So we applied Inspire Data Model. We use habitats and biotopes, Inspire Data Model, which is very simple. It actually asks you to provide identifier, to provide the geometry and the classification of the habitat, of course. And then if you have data, you can include the data on the species and the vegetation. But what we actually needed was, for us, the problem of the semantic. We want to see what are the code lists which are required. There are 3 code lists. All 3 of them are managed by European Environment Agency. The first one is the UNIS, European Nature Information System. When we tried to map our habitats, we see that it's very broad. It didn't provide the precision for the type of the habitat that we have in Canaries and probably in Micronesia. It didn't provide enough specific. We were losing actually the information. The same thing will happen with the Marine Strategy Framework Directive codes and the Habitat Directive codes. It was too broad. But actually, the Inspire model on the habitats has a possibility to include a local code list, which we actually did it. We use the local habitat name. And actually, we include the Spanish inventory of marine habitats for this mapping. We develop quite simple registry on our infrastructure, and we actually map it. And in the final, from 176 habitats, we actually get, with the Spanish inventory of marine habitats, 43 categories. It was actually quite detailed for our system. We were also talking with the people from European agency about the UNIS system, and they said that the UNIS is actually in the revision, and they're going to update this list. So it's going to be, probably we are going to go update this data set. So on this slide, you can see one of the smallest island what we have. It's La Gomera. It had actually within the 38 different habitat classification, but with the new classification which we provided, just 14. But what is most important actually that the same habitat classification is for the whole archipelago. And we can actually identify what are the habitats that are compatible with the aquaculture or the mineral extraction, etc., etc. We also included the data on the marine species habitats because we also have it. So we use the UNOM classification. And finally, we developed the GML file with using the Humboldt alignment editor, classical mapping. But we didn't go for this architecture like we tried before with download services. We went for something more simple for the Atom services to share it. But also we know that this product will have quite lots of interest in the Canaries, from the research institution, from the administration, even the private companies going to be interested, like scuba dive companies, scuba dive clubs, and something like this. So I don't know, it's a good idea to provide them GML file. It's actually expert spatial data. You have to know how to deal with it. So we wanted to provide something flat. So we flat the Inspire data model. We first flat just compository attributes, and we have a geometry, 2 attributes related to the Inspire ID, namespace, and local ID, and then the habitat schema. Is it the EUNIS, is it the MSFD, or is it the habitat? And then actually the classification. But we included in the file information what we have it. We had 3 types of the classification and the species. So this is how we actually deal it with the flattened, more extended data model. So we had place for the UNIS, for the MSFD, and for the local classification. But what we actually need, we need a shape. Because this is what actually their people use, and this is what we needed. So how to get there, we actually just, the shape, the problem is that it has it doesn't allow more than 10 characters within the name of the attribute. This is the problem with the shape within Inspire compliance. So we reduce it, and we get something like this. It's quite simple. I believe it gives the idea what is it, and we have, when we open just one feature, you have this kind of information. But the one thing what we actually do, this mapping within the Inspire names of the attributes and shorten name, we include in the metadata. So this information then it's available. We share it very simply with the GeoServer, download services. It's very simple to share, and it works quite well. But just not to say that we are not sharing the Inspire, we're also sharing, as I said, Inspire compliant file within the Atom. So thank you for your attention and the patience to listen.
The theme of the conference is inspiring the user. Are you tracking how people are using the data?
To be honest, no. For now, but this data set actually, we finalized it in this summer. Mm-hmm. So even we expected that there's going to be interest, it's until now, it's not that we harmonize this data set that's going to get be interested.
Yeah, so I look forward to seeing what happens with that.
All right, good morning everyone. My name is Arie Duindam from the Dutch Cadastral Office. Totally different subject, so we have to switch a little bit. I will be talking about, actually the title of my presentation is almost a summary. We're building a new data set for planned land use in the Netherlands, which is quite different from what we have at the moment. So I would really like to share that with you. We don't just do it because we like to change data and things, but there's really a big driver in the Netherlands. It's called, in Dutch it's called Omgevingswet, Environmental and Planning Act. It's already published officially. It will go into force around 2021. So you see this already, this is a big development in the Netherlands. It's already going for 5 years. That will only be the start. And so we're really in a big transition from spatial planning to something more integrated. The reason for the Environmental and Planning Act was basically to combine and simplify regulations for spatial projects. So like in the Netherlands, it's really difficult to start to build something or to do something in the if you want to build, for instance, a house or you want to build a company, it's really difficult because we have many laws. Every law has its own regulations. Every legal framework has its own systems, so it's really fragmented. So the idea is that we make it more consistent and also more in line with the EU environmental legislation. So we see already the scope of this development is really integrated. So it's not only about spatial planning, that's the domain where I come from, but it's also about data, about buildings, infrastructure, water. Well, you can see it on the slide, actually the whole physical environment. So what we want to reach is that we say, okay, now we have like 26 different legislation frameworks with all our own data, our own things, and we really want to reduce it to a single new legal framework. And it also means that the data that we provide today about planned land use theme will be changed actually quite a lot. It's called a paradigm shift. So it's really a different way of thinking in the Netherlands about spatial planning. We have a big spatial planning culture. Most of you will probably know this in the Netherlands. Everything is planned. Every square meter has its own destiny, and that will really change. So we will change the approach from what is allowed at a certain place to what is possible. So you see this is already a totally different approach actually. Now the policy is per sector, what I already said. It will be much more integrated, processes as well, the information as well. So it's a really big integration move actually. And the thing I want to talk in the second half of my talk, that is the data, because it's an Inspire conference, so it's also about data. I'm already jealous about the previous speaker. He showed very nice map, and that's one of the problems that we have at the moment, because we did provide a lot of map data for spatial plans in the Netherlands. But paradigm shift is also moving away from maps, so to say. Of course, it's all GML and geodata, but it's actually moving away from a geocentric approach to a more rule-based approach. And that is actually quite interesting, but also challenging. I already said every legislation, every theme in the Netherlands had its own systems. So it was said, okay, we need a new infrastructure for this integrated new legal framework. So we're building actually in the Netherlands with all the partners and stakeholders a new digital facility. It's called the Digitaal Stelsel Omgevingswet. So this will also be, there's also a big transition from our sectoral approach to an integrated view. So what we have at the moment, Cadastre delivers dataset, actually the only dataset that we deliver to Inspire for the theme land use and then the sub-theme planned land use. It's called Ruimtelijke Plannen in the Netherlands. We have data provided as from 2009, where we had the first digital dataset actually available. We have at the moment more than 60,000 digital plans available, so that already shows a big fragmentation. We have less than 400 municipalities in the Netherlands, but we have 60,000 spatial plans. And it's more or less map-based, so that's the current state of affairs that we have at the moment. So if you look at the new data set that we will be inspiring, and it's quite kind of cool, so that's a bit advertising from my side. We will provide something very cool. It will be available from 2021 around. I think we'll start maybe a bit earlier. We will also deliver that from we're responsible from the Dutch cadastral office to deliver this new data set, and it's really planned as a new data set. So it's not, it will be built up next to the existing data set. because it's so different. And you already see we expect around 500 physical environment plans, and it's not 60,000 anymore. So it will be less plans, but much more data. And there will be a big transition period as well. So it will not just be on day one that we have this new data set. This new data set will start to build up in a harmonized way, of course. But the transition period will take to 2029. So it's really a long period. And this rule-based approach is really interesting. Well, here is some advertising picture. You see, it's really a big transition in the Netherlands. It started 2013. The real transition will be ending in 2029. So what are the characteristics of this new Planned Land Use dataset? It will be very interesting on the scale because it's integrated. So it contains all the different themes that you can talk about in Planned Land Use. But it will also be what I already mentioned. We'll make a shift from like a map-based approach to really rule-based approach, and I'll tell you in a moment what that means. I'll have some UML examples of that as well. And what I also mean with rule-based approach, you see a real integration between the legal documents, like really the rules put in wording in articles. Yeah, this like the legal framework, also from the local plans. So like municipalities, they make their rules about what is allowed in certain parts of the municipality. They make rules about noise levels. They make rules about a lot of things. And it's the same for the provinces and the water boards and the central government. So all these rules, they actually exist in words and not in maps. So that gives a lot of new possibilities, but it's also challenging because the previous speaker had nice maps. I don't have them at the moment because I don't know how to make them. So if you look at the base geo model of our current data set, then really every planning object, we're talking about planned land use, every planning object is in fact a geo object with attributes. So that is all very familiar, I think, for us. We can easily create a geo data set and we have all the attributes and we can talk about harmonization. But the thing is that what we're making in the Netherlands, this integrated thing, we have rules. So we don't have geo objects, but we have rules about planning objects. And they are valid at a certain location. So you can say, okay, we have a rule about noise levels and this rule applies to a certain part of the area. But the basis of location is found in the rules and it's not in the basis. It's not a geo model with attributes, but it's more like a text model where location and map data is actually an attribute of the rule. So that's a very different way of thinking. I could maybe, if I think I have some time. If you look here, this in Dutch, so I have to translate this for you. This is a concept, by the way, so it's not finalized. But we see here an object type, juridische regel. This actually means a rule. So it's just text. There's nothing geo. And you can have rules about functions, like the function agriculture, or the function residence area, or the function industrial area. So we have rules about function. We can also have rules about activities, something that you do. Can you start a small-scale environmental touristic facility somewhere in your municipality? So that's like an activity. We have some norms and values. They come more from the environmental department. So we have rules about things, and these things, they could be, or they will be, available at a certain location. So you see really that the base geo model is not geo-rich. So if you only take the GML from our data, you will not recognize anything because we don't have attributes on the geo side in the basic solution. Of course, we will deliver the data set harmonized to the Inspire. So we have to like translate it back if we want to produce maps. So at the moment we don't have maps. Of course, we will have them. There's a lot of people ask for that. Can we produce a map of all these activities? Well, we can, but all the relations are the other way around. So they start in the in the rule-based. And I think this afternoon there will be a very interesting talk from my colleague Erik van Kapelleveen. He will go in more in detail about the implementation of this whole idea. So I'm more like telling you the idea that in the Netherlands we're really changing the way we model data around this planned land use theme in the broadest sense that we can think of. And the implementation is something that's also challenging. So we're also talking about harmonization then. So just providing the geometries would be meaningless because they only get their meaning from the legal part of the document. Also, something else that we already run against in hackathons that we need and in the interaction with the industry is that we follow a JSON first approach. So it's not like that we provide map services and feature services. But our first approach is to deliver a JSON file, JSON APIs, and that makes sense because it's not geodata per se. So we are delivering rules with attributes about rules. So view services at the moment is not trivial. We have to study that, and maybe Erik will tell something about that in the afternoon. Download service also not trivial. Of course, we can provide the download service. But to get meaning from that, we all have to do some work. So it's a bit away from our comfort zone as geo-information specialists, so to say. So that, I think there would be, I really wanted to share this with you at this moment. We haven't finished the implementation. We will continue to work. But our land use, planned land use spatial planning theme in the Netherlands will make really a big move in the next year. So yeah. That's actually my message. And so it's really exciting times for us. We're really making something new, but there's a lot of work to be done, what you can probably see. So thank you for giving me the opportunity to share this with you.
I think it's interesting to look at how you use geoinformation as an underpinning of rules, because that allows people to make decisions, which is ultimately what they're doing.
Yeah.
The question I wanted to ask is, you're looking at spatial location, but also do you consider temporal location in the rules?
That's a good question. Yeah, definitely. Yeah, because the rules change over time. And we're in this big program, and we have part of the architecture is that we also have a temporal model. So it's not just the rules today, but it's really the whole idea of rules in the Netherlands, also the legal side. If you go to court, you have to, your case will be held against the rules at the moment that the case was happening, so to say. So this temporal aspect is also in the legal context it's paramount, it's really important. So this will be translated to the data set as well. So what we see is that we will be providing data with a very rich time model, actually. And then we have even different time axes. So like the axis, what was legally valid at a certain point in the past, but also what did someone know at a point in the past? What could he have known? So we have different ways of traveling through time, actually, and this will come to the geodata set as well. Is the expectation at the moment. It's an interesting question. Yeah. It's also not very easy to build that. Yeah.
Good morning. Thanks very much for a very interesting presentation. In your model, you have location. How are you going to represent location? Because if I think of urban planning issues or regional planning issues, scale still has some pretty strong relevance. So there's a question for me, at least, about representation of phenomena. In this audience, we all know that very well. And then I was curious if there was any overlap with vocabularies, things that maybe come from semantic web. Have you engaged with any of that kind of crossing over between what is location, whatever that word may mean, in the planning context, and any terminology that you could pick up on to represent location? Thanks.
Yeah, actually you are asking a couple of questions. First one is the representation part. Of course, we will provide APIs, so the representation is also, it's partly is that also the responsibility of the consumer of the API, it is also of the web service. Of course, we also have like a central tool. We call it a viewer. And you can see the rules on one side, and you can see the locations on the other side, and you can really say, okay, this rule, what location is part of that. And then, of course, we get all these difficult questions about if you zoom out and you have, many megabytes of, then we have to do something. Again, we're thinking about providing vector tiling, but basically our base solution is that we provide the coordinates that belong to this activity where the rules are about. So they have some different levels. And the other question that you asked is also very interesting. You get good questions. It's nice. It's about actually the semantic layer of the whole. I didn't talk about it now because my talk is not about the whole new facility. I just wanted to, in 15 minutes say, okay, this data set is really, really different than what we have now, but we have indeed a semantic layer on top of this data set. It's partly based in information model, but also in a catalog, which is a linked data solution for meaning of things, because if you look in the legal documents, it always starts with the meanings in the first article. And somehow there will be a relation with the catalog that we're building up in parallel to this data set. So it will also have links to this catalog. So catalog is definitely, for the semantic layer, is definitely part of the solution, yeah.
How are you going to reduce the number of plans? Is there a new organization or just because of new technique?
Yeah, it's a nice question, yeah. Like now, if I zoom into one municipality in the Netherlands, they have a few hundred plans, and they're all, because sometimes you need make a new plan for part of the city because you have some spatial developments there, and it will like exist next to all the other plans. So it's really fragmented. And in our new legal system, it is obligatory for a municipality to have one plan. But what we will see, it will be one plan, but then these temporal aspects come into play because the plan will be dynamic. So it's one plan, but it will change probably every week. So we have to time travel through this plan. I think it's quite a challenge for the municipalities specifically to provide this dynamism in their one plan. Basically, they decide all the time to change this plan instead of making a new plan on top of all the other ones. So that's the difference of a base approach, actually. So that's why we have this big reduction. But the one plan will contain all the information, whereas first the information was scattered around a few hundred plans for each municipality. So that's always, that's also good.
Do you also have transboundary, transnational plans, and how do you deal with them?
Yeah, it's a good question. I've been thinking about it while I drove here. I never heard anything about it from the program we're in at the moment. Maybe it's there, but I haven't come across it actually. So it's really now per government is actually its own jurisdiction, is making plans, is providing data. So it's really like a Dutch approach. But maybe it's somewhere else where I don't know that.
Okay, good morning, ladies and gentlemen. I'm Pascal Laurie. I'm from the Minister of Ecological and Sustainable Transition in France. I'm going to present you the outcomes of a working group we set up in France. It's the name of the working group is GMEL, but it's not meaningful in English. It means geoinformation for the coast and the sea. Please note this presentation has been prepared by Agnès Laure from the French Hydrological and Oceanographic Service in France, and Pierre Vignier from CEREMA, a public body. So they are the expert of the topic. I'm only the speaker today. Okay, so about my presentation, I will first talk about the features of this working group. Working group connected to the National Council of Geoinformation in France, which is a coordinating structure according to INSPIRE. The different coastline, because we have different coastlines. Geomorphological coastline, one of the coastline we have, and the land-sea boundary and the perspective we have in this group. So first, the features of this working group. It has been launched in 2016. Previously, there was a working group between 2011 and 2015, but it ended in 2015 because we didn't find fundings to produce the data. The goals are to identify core reference data sets in order to support public policy, and then to set up modalities to create. So we go forward, we try to create the conditions to produce the data. We don't only write specifications of the data sets. It's a very active group with many stakeholders involved. Every meeting we have 20 to 30 people. Mainly public, from the public sector, local authorities, and state at different levels, national, regional, and public bodies. So we have the CNIL legitimacy and the state support. A public body is managing the working group. Here is production of the group. It's it's to explain the different kind of limits we have on the shore and in the sea. As you can see, it's a very, very complex domain with many different boundaries. So it was the purpose was it was a pedagogical brochure, in fact. Some of these boundaries are already in free access with a link you can see here on the website limitmaritime.gov.fr. So about the coastlines, we have different kind of coastlines. When we did the inventory of the different core reference data sets, we identified mainly two types of coastlines: a geomorphological coastline to measure erosion and accretion, and a land-sea boundary. We changed the name because we didn't want to have to use coastline two times, in fact. So the geomorphological coastline is composed of markers produced in the frame of the National Indicator of Coastal Erosion, because, you know, on the Atlantic shore we have a lot of erosion in France. And this geomorphological coastline is downloadable on this website. You can see here the link. It's measured by photo interpretation with the help of shore orthophotographers. Here you have an example on the Oléron Island on the Atlantic shore. What you can see, the different bars in green, it's the accretion, so the coast is growing, and in brown it's the erosion. So you can see the difference. So we don't have only erosion; we also have accretion on the Atlantic shore. So it was the first type of coastline we need to measure erosion, but we also need a high-scale coastline for other uses. And this coastline is high-scale coastline. It covers knowledge and regulatory needs. It's in fact, as you can see on the picture, it's a cross. It's a cross of astronomical high water mark at 120 tidal range in normal weather. It's the cross of this high water mark and digital ground, altimetric digital ground model. On the picture on the left, you can see on this one, you can see two. It's a natural coastline. You can see two coastlines. The standard one we already produced a few years ago, but it's not high resolution. And the second one in magenta, it's in red. It's a high resolution coastline. So this is on a natural coastline, and here is in a harbor. You can see the difference. It's a very different way of producing because we have dikes and wharves and so many man-made. It's a man-made coastline. The results are very different. Okay. So we will produce this coastline on mainland France and overseas territories too. The difference with the standard one is the accuracy will be best than 10 meters. And it's INSPIRE compliant, of course, as we are in an INSPIRE conference. It's not only a line, you have also different information with. We know if the coastline is man-made or natural, if the nature of the surface too, is it round sands, is it rocks, and the precision. It's not yet produced. So it's a project, but we have two areas on the Atlantic Ocean and the Mediterranean Sea where the coastline has been produced. The producer will be the French National Hydrographic and Oceanographic Service for the tidal model, and the French Mapping Agency for the digital altimetric digital ground model. The budget is 360,000 euros. So we didn't yet found the funding. So it's we'll have to do till the end of the year, and the production will take one year and a half because it's a very, of course, we have a long coastline, 15,000 kilometers to produce.
So hi everyone, my name is Jumi Tost. I'm from Finnish Geospatial Research Institute, and I work with Christian Koski, Juha Oksanen, and we have partners from Denmark, and their name is Ida Maria Reiter and Henning Sten Hansen. And today I will be talking about the Baltic Explorer, and I will start my presentation with what is Bonus Basmati project, what is Baltic Explorer, what's the service design and user requirements, and what are the mock-ups that we did it, and the current progress, and what we're going to do next. So Bonus Basmati project is all about creating decision-making softwares. And our major goal is to create intelligence system to inform multi-level governance organization in the Baltic Sea region. And we care about the ecosystem, service approach in this manner so that we try to sustainably allocate marine space while preserving the environment. And each of our partners is working in different work packages. And the first group is focusing on the governance and maritime spatial planning, and the second group is case studies, where we are testing the software, and third group is focusing on the ecosystem services and pressures, and the last group is focusing on impact assessment framework, and Baltic Explorer is covering all of them. What we promise in the plan while we apply for the funding is that we will create a multi-channel platform offering an interactive web map and a large multi-touch display for accessing, displaying, and analyzing harmonized cross-border data from marine spatial data infrastructure available in the Baltic Sea region. So the multi-channel means that you can use the application in every channel. You can use it on the phone, you can use it in the touch screen, or you can use it on your computer. And interactive web map, it should be web application. It's not a desktop application or standalone tool. It's a web application. And we will use first the existing data, which is based on the HELCOM's data, but we are also producing our own data. And the second issue about Baltic Explorer, we are trying to support the collaborative setting of the for different users. So different users have different interests, and with this software, we want them to make their voice heard. And it should also allow negotiations between the regional stakeholders. And based on that, we will let them put their values, and they will try to find the optimal solution for any cases that they are dealing. It's, of course, to make it compliant with the system, we use open standards, and we are trying to use the modern web technologies, and it will be built on the open source components. So to define this Baltic Explorer, we needed to define what the MSP planners and scientists or stakeholders and all the others need. What they need. To do that, we started a listation of user requirements from literature. So we go through hundreds of papers and handbooks, and we also try to identify the needs of MSP planners from different projects. But this was not enough. We needed to talk to them, and we needed to find the optimal solution for their needs. And for that reason, we use the value proposition canvas as service design principle. And so the basic idea of value proposition canvas, we ask experts, as you can see, what are their pains, what they do actually, and what are their pains related to marine spatial planning, and what they would like to get. Then we gave them about half an hour to answer these questions. Then we also expected them to give their own answers for these questions. So what would be the optimal pain relievers for these problems, and how can we create more gains for them, and what could be the optimal product for them? So based on this, we gathered a lot of information from different experts, and we clustered them all together. And based on this knowledge from literature review, value proposition canvas, handbooks, and reports, we identify our user groups, and we we created the product backlog for that and user stories and use cases. And of course, based on that, if we have more data for certain features, we start to tell that this is more important for MS people than the other cases. If you want to give example for this, so our user groups can be scientists, researchers, MSP practitioners, stakeholders, and all users for this system. Scientists can be anyone who is working for scientific development in MSP, for instance. And after defining the user groups, we defined also the user stories. So in VPC, in value proposition canvas, they give information, for instance. I would like to have a mapping platform that utilizes existing spatial data infrastructures and improve resource management. And actors for that, planners and planning organizations, and we try to identify their user goals. Spatial resources are distributed and organizations are create or buy spatial resources to complete their tasks. This causes extra efforts and all the other problems, so we need to make it sure that the data is available for planners. And we try to describe it, and we also put at the bottom of user story what the actual input was. And then we started to define our use cases. So user enters the Baltic Explorer, and they open the map application, and they try to see different layers. And we give them also the priority as we conducted the prioritization. And after that, we try to also identify how can we place the Baltic Explorer, this software, in MSP processes. So based on that, Baltic Explorer will analyze existing conditions and analyze future conditions, but we will not develop plan, or we will especially focus on the analyzing the existing conditions and future conditions. And after that, we try to find out what could be the main features of Baltic Explorer. So it will be a Data Explorer portal. You have lots of data where you can see it. So it's just a basic data exploration platform that we have in many countries. And it will do this cumulative impact assessment on the web, which is not very common. And it will do suitability analysis using multi-criteria decision analysis, and it will be also collaborative. There will be also a collaborative application. So after deciding the features of the Baltic Explorer, we started to design the mock-ups. And because we said that it will be multi-channel and it will allow us to use this touchscreen devices, our friends has done great mock-ups that what would be the optimal software that we can use it in multi-channel touchscreen devices. And also, how can we make this cumulative impact assessment tool? Can we rescale the input data? Can we edit the sensitivity matrix in there, or draw your own geospatial features? And it should be also mobile compatible. So these are just mock-ups that we are that comes to our minds, what would be the optimal solution. And now we are at the stage of prototyping. We have this basic Data Explorer. In Data Explorer, you have hundreds of data layers related to status assessments, backgrounds, shipping, biodiversity, pressures, monitoring, and we will have more data from our German partners. And it has these features for legends, opacity, and sublayers, and as well as pop-ups and base maps. And the next tool that we are developing is this cumulative impact tool. So based on the formula that how you assess the cumulative impacts, you have the pressure, you have pressure layers, and you have ecosystem components, and you have also sensitivity weights, sensitivity matrices that try to identify which pressures are affecting which ecosystem components caused by the human uses. And only place where you need the data, where you need the judgment, is this sensitivity matrix. It's based on the expert judgment. So we start to think that what could we do with this sensitivity matrix? Probably the best solution would be that experts could change the values and see what would be the cumulative impact if certain pressures are changed. So pressures are, we have 90 layers, which is visible on the system right now, and we have ecosystem components. They are also 36 layers, and we try to identify basically each pressure affecting the other ecosystem components. And so, as I said, if we are going to show it in the sensitivity matrix table, we have columns over there which is representing ecosystem components, and on the top we can see each pressures, which is 19 different pressures. So the experts can change them, and they will see the results on a map, on a chart, and as a result. So as you can see easily, the pressures on the coastlines are higher than the far away from the in offshore areas, let's say. And when you click each cell, you can see the values. In nearby Finland, it's like 6.78%. But this is just the stage that we are still developing the application, and we are going to make it much more nicer in the future. So what we're going to do next is that we are implementing the system as agile process. We are not saying that Baltic Explorer definitely is going to be like this. We will shape it according to needs of the MSP experts, scientists, and decision makers. And in the next, we are going to create a minimum viable product for suitability analysis. And we will also put improvements on user interface and performance, because we are trying, for instance, in cumulative impact assessments, we are combining 684 layers all together, and it takes a lot of time. And all those are raster layers. And we are trying to give the capability of on-the-fly modeling. And it's in that sense, performance is key for our cumulative impacts assessment tool. And at the end of the project, by 2020, we will test the system on bonus basmati case studies. And yes, that's it. Thank you very much.
Indeed, just picking up on what John said. So are you continuing the engagement with the stakeholders throughout the process?
Yes.
It's good with your kind of requirements, but are you also asking them about how they want to see the end product, etc.?
Yes, we are trying to conduct all the time the workshops for them, and we are willing to understand their problems, what would be the optimal software for them. And we are going to conduct another workshop in November to engage the stakeholders and put their values on each map. And it will be, the basic idea will be put their ideas on Data Explorer. So what are the most important areas for them, and what would they like to do? And so we try to make their voice heard with this software. And yes.
Thank you for your interesting presentation. I wanted to ask you, do you have any idea of these needs of the planners? And I know that you have another, but probably you have idea what their perspective needs. And I wanted to ask, because you have actually Helcom, and Helcom provide very nice products. So is the requirements of the planners are actually covered with the data from the Helcom?
Yes, they provide most of the data from Helcom, but we also try to find optimal data needs from planners. For instance, one of our key issues to focus on the resolution. So when most of the data are 1 kilometers, but it would be optimal to have 200 meters resolution, so you would estimate the wind farm's location better, because when you think a wind farm doesn't take 1 kilometer, but it shows on the map as 1 kilometer, square kilometer. So it would be better resolutions would make the analysis better. So we also try to focus on that area.
What is the role of InSpy? Are you using harmonized data from InSpy, and for which theme, if yes?
Am I using harmonized data from
InSpy?
Yes, we use the existing maritime spatial data infrastructure, which is available from Helcom, but we try to also create more data for our purposes.
Any more questions then for Umit? Okay, thanks very
Yes,
much.
thank
Really
you.
interesting presentation. Thank you. And Eduardo?
Yeah, it's me. Thank you.
Good morning. Thank you for coming. I'll be talking about cross-border geodesign. So they have planning with data, having feedback from data on ideas and plans. And we have a specific case study on a wind turbine planning. And I'm doing this work. I'm affiliated with GeoNovum, where I'm really trying to think about what is the Inspire and how can we do cross-border aspects. The main development we did at the FU University and at Geodan, it's a private company, where we do the technical developments, and the TU Delft supports us with the noise models. I think it will come clear in a few seconds. One second. So, it was my affiliation. 25 years ago, I was playing this game. Somebody recognize this game? From the audience? 1993? Yes, what is it? SimCity. SimCity 2000. It was very exciting because we could actually change the space, put the power plants, put new roads. You could get feedback on how your city was performing, how was it actually going. I was very fascinated by this, which led me then to my entering into the geography world and the idea of using planning. Nowadays, we have the concept of digital twin. The digital twin is the idea that you abstract from reality, you create a digital copy of your assets. So then we can use your digital copy of our assets to do simulations, to do performance enhancement. And the idea is that, okay, now that we have a digital copy, how can we best understand how it performs? So now we have this idea of, okay, let's use this digital twin for planning. That's what we call in the geodesign, that we iteratively, so we change something, and we get from this digital twin the performance. How is it performing in our system? So we don't have a digital twin of an object, we have a digital twin of an ecosystem. So the whole area, the 3D environment, all the different processes. And we try then to, by changing this ecosystem, to be informed what are the consequences, what are the best options for us. And that's what we call then geodesign, because we do it in an iterative process. So very much we change something, we get immediate feedback. Very much with these decision support systems, that we get this immediate feedback from the system. And we're trying to apply this to wind farms. So in the Netherlands, we have a very strong commitment. We'll try to have much more wind energy production. So the different provinces, municipalities, they've made agreements by 2020. We should have a very large share of our energy being produced by wind. But of course, there's a lot of aspects involved. So we went into the computer game environment. So we wanted to have a very interactive system, and that will help us to do this planning process. So what will be the fastest that we could do? We said, okay, we just want to pick up a wind turbine and be able to place it on the landscape and be able to understand, well, how is it performing, how many houses are affected, how much it's producing. So it was really this idea. And being so interactive, we went to the game engines. So we use a game engine technology. It's a Unity game engine. And as we pick up with our mouse a wind turbine, we try to play it in the landscape, and we immediately get feedback of how many houses are affected on the top corner, so how many houses, what are the noise levels that they can actually receive, but also how much energy is being produced by this single wind turbine. So the idea is that we do indeed use all these, the mechanics of geodesign, so giving direct feedback, and then with the data behind it for a very, very smooth planning process. So that was the outcomes of our planning. A lot of data goes behind the scenes to make it so easy that you can just drag and drop. We have a lot of data that we need. You probably recognize some of this. It comes later on, some of the Inspire annexes. But basically, we have the data. We use a lot of the Inspire services for accessing the data. We have the analytical tools are mainly in the browser, so it run on the client. And then we have the viewer that gives back the numerical feedback, the numbers, but also this visual feedback with changing the colors. So this will be, so there's a very complex model. So this is the sound model. So there's a lot of different effects that from sound. This we got from our cooperation with the TU Delft. So in the background, it's more or less, it's what's happening in the background. You don't actually get to see it. But for every single object, we're actually able to calculate if the sound model for different aspects. I mean, what is the effect of humidity? So you can change that. What is the diffraction of the sound bouncing off other houses? And finally, the geometrical spreading of sound. So I'm just trying to get you dizzy with all these moving objects. But some of them are very interesting for us. For example, also land use and the way that sound bounces on grass or on asphalt is different. So for us, that was also very important. So you see a wind turbine, if it's placed on if there's grass in front of the house, you get a certain noise level, and if you have asphalt in front of the house, you get a different noise level. So there's a lot of very data hungry, data intensive process. Here we have vegetation, same story. So if you have a lot of vegetation in front of your house, you get this absorption by the vegetation from the sound gets absorbed. So you get different noise levels for the houses depending on the vegetation that's in front of the house, and that is something we also have available. Last but not least, very important is also the noise. So you can actually calculate in real time the shadow. This is where the game engine really proves a very added value, because it uses a lot of the line of sight, a lot of computer graphics. All the computation is done on the graphics machine of the computer, so it makes it very, very fast to calculate this shadow analysis. We can calculate the yearly average, but also seasonal, but also monthly average. So sometimes it's interesting to know in overall for placing solar panels, for example. But sometimes it's more interesting to know, well, I have my birthday party, will I have shadow on my backyard or not? This is one of the last ones, again, from the computer engine. We automatically calculate the line of sight. So this is typically, it takes some time. In a GIS system, with the game engines, with the ray tracing, we can easily calculate if this object is has visibility towards a different object. So that goes automatically. In terms of the yield, we have then wind maps, so we're able to calculate what will be then the potential production of the new wind turbine being placed. So the costs, but also the benefits. And this is one of the most interesting ones. It also is related with the previous talk. It is a very dynamic system. So when you talk about restricted areas, the restrictions are not based on a static map, but they are actually based on depending on the object being placed. So the law says you cannot place a wind turbine closer than half of the rotor diameter of the wind turbine. So that means, so if I choose a very high and very large rotors, I will get a different restriction map than if I choose a smaller wind turbine. So that gives a different, it's a very dynamic component. So we've solved this by having many different wind turbines, sizes and different rotors, and we're able to produce different maps for them. But this is an interesting aspect that something might be allowed, and a wind turbine could be allowed in a certain place depending on its size. Yeah, and the existing wind turbine is also important because there's also legislation about how far away you have to be place new wind turbines to the existing ones. So the idea will be, okay, being based on the conference, I'm inspired now. What about from my own country? So we try to map all the data, because it's a very data-hungry system, to Inspire. And what we could find is that for us, very important is like buildings. So buildings is a very important unit. We get the building data with the WFS already currently. And that is, of course, inspiring. It's one of the inspired themes in Annex 3, the footprints even. There's building height, there's the elevation data that we combine with the building to create these 3D boxes. Orthoimagery for the background, terrain height model is also part of Inspire. Wind velocity is also part. Electricity demand, it's not there yet. So this is the idea is that how much electricity is actually being consumed in the area. Existing wind turbine location is also part of Inspire. The restriction elements, it's not. So this is where we talked about, okay, I can place a wind turbine if it's less than so many meters from a road. That is local law, legislation, and that is not part of Inspire. So this extra work that research will have to do to be able to use this tool. Vegetation also part, land use, and even humidity is also part of Inspire. Humidity has a very big impact on the noise levels that you can hear from the tool. We've published, so you can read more about these developments, both the modeling aspect behind it. This one, it's environmental modeling and software. And this year we launched this one where we specifically use the tool with the wind corporation. So in wind corporations, a lot of people from the area, they own the wind turbine, and then they decide together where should it be placed. So that's a very strong case study for us. And here we go into details on the suitability analysis and the multi-criteria. This is what this paper is about. So now we're specifically doing work now on the cross-border aspects. And so if you have examples or ideas of in your country where there's in one side of the country people are planning to build a wind turbine park, and that has consequences for the other side of the country, we'll be very happy to hear from you, and we try to use then Inspire data sets and to make it easy planning process. Thank you. That was it.
Quick question. Have you considered a similar approach for siting of offshore wind turbines?
Yeah.
Which obviously have a different set of criteria.
Yeah, it will, that's a good question. Offshore has so very different set of criteria need. We specifically do not focus on offshore. It is onshore that we're working on land. Because the idea here was also very much to build a community participation tool, and that's a very different aspect. So in theory, yes, it's possible. I see more advantages with in land because so many people involved, from the people that live there, the NGOs and things. yeah, so we don't have any examples at this moment on sea wind turbines. But indeed, like the visibility analysis, this could be very interesting. Yeah. So in theory, everything would work just the same. It would make a difference.
Yeah, just a quick other question. I think you should deserve the prize for the best slides anyway, because it was really beautiful. Thank you. But it was inspiring because I was thinking, would it also be possible to let the computer decide what the best place is? You know, now you have to move around and you suddenly see, all right, maybe.
Yeah.
So it should be possible.
It's a very good question. Yeah. So the question is, will it be better that allow the computer to make the decision of the best location? In the system, actually, we have a genetic algorithm that will be able to calculate, based on all the parameters, what will be the best location for the wind turbines. And we can run that, and the idea is that with genetic algorithms, we know a lot, and we can run it, and we can get a very good result. But we don't know everything, so we cannot put everything in the computer. The idea is that we can then run the genetic algorithm to create a kind of a base scenario, and then allow the stakeholders to freely move it. Because sometimes it's also difficult for them to say, we created that, because for them it's easy to say, when they have a blank canvas, oh, I don't know where to start. So they say, okay, we can start with 20. And they just run it, and then they will say, oh, I don't want it there. And then it starts discussion. So when you actually show them a solution, they're like, oh, that's not what I want. Oh, that's fine, then show us where you want it. And then they will move it themselves. And the idea of this hybrid approach of half the computer doing a certain distribution, and the other half the expert knowledge or the stakeholder saying, well, you know, that farmer John will never sell his land for this, and then let's move it just there, and that is a very strong combination. Yeah. Thank you. It's a good question. Thank you.
I have a background in urban planning. That's why I keep on asking all these questions in this session. So that's a really nice application. It's one of the most typical GIS kind of applications. I can even remember it was part of a European Commission concours. It's such a nice example. What's your favorite other application area for this kind of technology?
Yeah, it's a good question. Yeah. Well, it's a spatial planning question, so I'm happy you're here. All these questions. This is a very classic one indeed about allocation. What this technology of the game engine, we have another application that's really cool also, which is the location, the positioning of surveillance cameras. So because also very complex problem, and the idea of where, so that the users can actually say, oh, I'm very interested in surveying the roads, and will automatically try to position the cameras, but then the expert police officers, I mean, well, actually, I need it there, I need it there, and they actually manually. So this hybrid approach and direct feedback, how much is it actually achieving the goal? This is a very, I find it a very strong combination. And everything that is kind of, that we are sure that we don't know everything, we as professionals, and that's where this plays a very important role, because the expert knowledge will always know best the person of the area, the police officer for the cameras, or the people from this area for the wind turbines. They always know best, oh, this land is not, it will never get a wind turbine. And allowing them to do it a little for themselves, it always provides the best solution instead of a fully automated top-down solution. Yeah, thank you.
Okay, good morning, everybody. I present something advanced of our marine network data provide directly in linked data with inspired data model. Okay. The content is what was it, what we have till now, and then what we have done to improve the linked data that we have already implementing for the marine monitoring network, to include Inspire in the RTF element. And then some issue to solve or to improve or to a totally implementing system. So some years ago, we starting to think about implementing linked data in our organization. It's my organization, it's environmental agency in Italy. And we try to model the data with Spatial. So we have the Ancona buoy. This is one of the elements of the networks. And we try to map this one with the ontology to explain better the parameter and the measure that we have in each one. And of course, this is what is in place already, but representing the ISPRA implementation of link data for marine monitoring networks. Especially the RON is the wave parameter analysis of networks. And then we starting to analyze the environment monitoring facility data model and how to use this one in the link data. So we analyze that and we starting to transform that following the guidelines a couple of years ago about the commission on RDF encoding on the spatial data. So we see in the left side the ontology that we have implementing for environment monitoring facilities. And of course, we model all the class and all the properties, the data property or the object data property. And to have an inclusive element at the moment, we implement inside the same ontology also the observation measurement part, because we haven't already in place in the OGC a link ontology for this part. So we implementing together in the same place. So you can see the same ontology in the graph forms. And in the tail, if you're clicking on each element, you see in the left side, also in this case, that you have the environmental monitoring facility, where you have the description is defined by a reference of ISPIRE, and so all the elements that we need to modeling the ontology. Starting from this ontology, we have make a comparison with the previous link data model. So we compare the models to understanding which is the element compared with the data model, ISPIRE data model, environmental monitoring data model. And we're starting to implementing a link data, a link open data, but for course, the link data with ISPIRE elements. So you see here a real implementation in place that we have. And you see that the Ancona Boy is modeling with a specific class of environmental monitoring facility. Also in the above part, you have see the abstract monitor object geometry. So the geometry is also linked to a specific class for, of the model. And if you scroll down to the page, you see all the elements that describe the buoy. And you see that all the elements have ISPIRE EF classification. We're using ISPIRE EF classification as a domain because we are not sure in the world we have other namespace of EF. So it's better to use ISPIRE because this is very reference to the fact that this is the ISPIRE environment monitoring facility data. And you see that we can navigate through the data. So in this case, we can go to the single element, and we have the broad definition regarding where is the campaign, where is the program related to this buoy. So we have the sea area in front of Ancona, and also, of course, we have some element that describe. But if you come back here, it's quite interesting that also when we have some element is described by ISPIRE code list, we have the link to navigate through the ISPIRE registry and vocabulary. So you can click and you have the information regarding, in this case, the media value weather. If you come back here, also navigate through the link data, we see that we have also including some external reference. So what we have done is also including in the ISPIRE the possibility to integrate what exists in the world. So in this case, we take in account the OGC, the W3C element, but also in the case of defining some specific parameter, the WMO element. So if you click here, you go to the description of WMO page. So in some way. We not replicate the effort to describe something that exists when we have something that is not described by a spy, of course. And if you scroll down also in the same page, you have the possibility to see also the inverse relation with the other entity. So in this case, we have the possibility to navigate through the model, and we can go to the wave gauge or to the network. In the case of the wave gauge, we have the possibility to go to the observation measurement. So in this case, we have the observation element, the property to describe the observation property. And we integrate, as I said before, the observation measurement in the SPI. So you see SPI EF element, but of course, this one is part of the observation measurement part. And of course, we can navigate through this one. And you see that in this case, you have the description of observation. You have the possibility to scroll down to the specific parameter. And you see that when the parameter is not defined by SPI, we're using, of course, our internal definition. So we create a local ontology to describe the parameter that is not described by SPI. And if you click, of course, also in this case, on these specific internal links, we have the possibility to explore the process or the measurement. In the case of the process, we have some element. In the case of a specific wave, we go directly to see which is the parameter. In this case, we have the significant wave age with the definition of an attribute inside the data, so the data table, the data information that you have a specific attribute. These attributes also, oh, sorry. I think so, we go too fast, okay. You see that in this case, we're using the double 3C definition to describe the age of the height of a wave. So we're mixing Inspire with the other entity to describe the data model. And if you go more in detail, you have the possibility to explore the measurement of the buoy. And of course, you have also the possibility to download all the data related to the specific data time. So you need to navigate through the model, and you decide what you want to download. And you can download directly a table, a standardization table. Because also in this case, you see that attribute is the W3C attribute defined in the previous slide inside the data model, the linked data model. So more or less, this is what we have in place, what we have implementing in terms of linked data Inspire of the network. But there are some issues, some elements that will be improved or solved also with the Commission, because in some cases there are some other ontology that is not officially published, like the base 2, some element that is related to all the Inspire data model, and we have to solve some element regarding that. So, to go to the conclusion that before of the end of CR, the idea is to implementing all the data set, also taking account the oceanographic geographic feature element. So is there another part of another data model of SPY that is related in this case to this marine network, monitoring network, because of course we're talking about oceanographic elements. And, and also try to explore how to better define some other elements related to the SPY. But we need also to solve, as I said before, the possibility to publish the SPY ontology, because I suppose that SPY ontology is something that we have to develop at the Commission level as an internal registry. So not each organization published their ontology, but someone at central level have to do that. Focus, sure. Then we have some conflict with existing ontology on the web. So in some way we have some replication that we identify, especially on parameter and property. In some way we have to identify which is the best way to model the data in the ontology. And then probably we need to do that. We need a feasibility study on integration model, also take in consideration the possibility that this monitoring network is used in marine framework strategy directly. So we have to, in considering that this is part of a bigger picture that we have in place. That's it. Thank you.